In this section, we're going to look at other methods for solving quadratic equations other than the zero factor property, which has been the method that you've been taught so far. So at the top of your notes, let's look at the first box. It says recall the quadratic equation, an equation that can be written in the form of ax squared plus bx plus c equals 0 is called a quadratic equation. That's considered standard form when it's written in that format. Now, up to now, we have used the zero factor property to solve quadratic equations, meaning you factored. So there is a chart here on this page that I'm going to continue to refer to throughout a couple of videos, and it lists the different methods that you're going to learn for solving a quadratic equation, their advantages, their disadvantages, and how you prepare the equation to get it ready for solving using that method. So I'm going to review quickly the factoring method, which we've been using up to now. Its advantages are, believe it or not, if you can factor, it's going to be the fastest method. The disadvantages is that not all polynomials are factorable, and some that are factorable are very difficult to factor. But assuming that you're going to be able to factor it, the equation preparation is you get it equal to 0. So it has to be equal to 0. So let's drop down before we complete the chart and let's do a quick review of using the zero factor property and solving a quadratic equation by factoring. So you're given the equation 3x squared minus 5x minus 28 equals 0, and it says to solve it by using the zero factor property. So I always teach jotting down that acronym for the property on the left and then following what those letters tell you to do. Get it equal to 0. It already is, so we don't need to do anything. It's already prepared. Factor it. It definitely has not been factored yet. The factoring method here is the long process. So I multiply 3 times negative 28. That gives me negative 84. And I want factors of negative 84 that combine to make my middle term negative 5. Not knowing the factors of 84 off the top of your head perhaps, what we're going to do is just list them all, and at the end we'll figure out the ones that work and what the signs should be. So we're going to start with 84 times 1. I've taught this method before. Take the bigger number. If it's even, divide it by 2. Multiply this one by 2. Do it again. Divide by 2. Multiply by 2. You continue to generate factor pairs that multiply to make 84. Now 21 is not divisible by 2, so I'm going to divide it by 3, which means I have to multiply by 3. Go to the bigger number again this time, which is 12. It is even. Divide it by 2. Multiply by 2. And at this point, if I go to the bigger number and divide it by 2, it's going to take me back to here. So I'm going to start going backwards. I can see that there is a combination of factors that will give us a 5. Now I need to figure out the signs. To get a negative 84, I need a negative times a positive. But to get a negative 5, when I combine, it means I need more negativeness than positiveness. So my negative number is 12. Now what we do is we bring down the first term. We break down the second term into those two pieces, minus 12x plus 7x. Bring down the last term. Now leave it equal to 0. 1, 2, 3, 4 tells us to group. The GCF of that first binomial is 3x, and we're left with x minus 4. Bring down the plus. The GCF here is 7. We're left with x minus 4, still equal to 0. These match, so I know that that is my first factor, and my second factor are the numbers on the outside. 3x plus 7 equals 4. So that is the factor part of the zero factor property. Now we apply the property, which means set each factor equal to 0 and solve those two little equations. So here I add a 4 to both sides and I get x equals 4. Here I subtract a 7 and divide by 3, and I get x equals negative 7/3. And we have our two answers that we got by using the zero factor property and factoring. All right, let's go to the second type of solution, and this is a new one. That is called the square root property. The advantages of that, it's the simplest method if the equations look like this, something that got squared equal to a number. The problem is very few equations are given in that form. Most equations are not given in that form. They've already been FOILed out or they're in some other form. But if they are, this is a very easy method. The way that you prepare it is you isolate, so that's the key word, whatever has been squared. So I'm going to set this aside and bring over some sample problems to do of the square root property. Looking at example 2, I have x squared equals 5. Right, here's the thing that's been squared. It's already been isolated, so I'm going to take the square root of both sides. That's how we solve it, just like we did with the Pythagorean theorem. The square root of x squared is x. The square root of 5, I want both the positive and the negative root, so it's plus or minus square root of 5. And that is how I get my two answers. X equals positive square root of 5, x equals negative square root of 5. It's not really necessary to write it like that. It's perfectly fine to write it like this with the plus or minus. Let's try another one. Here, what has been squared is not isolated because there's a negative 48. So in order to isolate the term that has been squared, I'm going to add a 48 to both sides. To continue to isolate what's been squared, I'm going to divide by 4, and I get x squared equals 12. Now the squared term is isolated. I can take the square root of both sides. Square root of x squared is x. Square root of 12 is plus or minus. Now I got to break this down because it can simplify. That's a 2. Now watch where the 2 goes. It goes right in front of the radical. So you end up with x equals plus or minus 2 radical 3. So the plus or minus is in front of that 2. All right, let's try one more. We have example 3, x minus 5 squared equals 36. This is a very important one. It's a little bit different. What's been squared has been isolated. So I can go ahead and take the square root of both sides to undo that squaring. So I have x minus 5, because the square root sign and the square sign undid each other, equals, remember, square root of 36 is plus or minus 6. Now at this point, I have to split my equation into x minus 5 equals positive 6, and x minus 5 equals negative 6. So I had to split that symbol there, the plus or minus, and solve two equations in order to get my two answers. So I add a 5, and I get x equals 11. There's one answer. I add a 5 again, and I get or x equals negative 1. So my solutions are negative 1 or 11. Now, example 4, I want to compare the difference between an equation that has a radical sign in it with an equation that has something that's been squared in the solution process. We've done this kind in other sections and other modules. This is the kind we're doing right now with the square root property. So let's look at how they are different. So on this one, I see that I have a square root. To undo a square root sign, I have to square. The radical has been isolated, so I am free to go ahead and square both sides. They undo each other, and I'm left with 4 minus x equals, FOIL this out, and you'll get x squared plus 4x plus 4. I now have a quadratic equation, so I need to get it equal to 0, because the only options I have for solving it are the zero factor property. It's not in the correct format to solve using the square root property. So that gives me x squared plus 5x plus 4. We're going to subtract a 4 on both sides, and I get x squared plus 5x equals 0. Zero factor property, so I'm now going to factor out an x and set each factor equal to 0, just like we did on the other page when we reviewed this. There's one solution, and here is my other solution. Now, because I squared, I have to check both my solutions. So I'm going to check 0 in the original equation. Square root of 4 minus 0, I'm putting the 0 in for the x's, equals 0 plus 2. Is the square root of 4 equal to 2? It is, so that checks. Now we have to check negative 5. Being careful with signs. Square root of 4 minus negative 5, is that equal to negative 5 plus 2? Is the principal root of 9 equal to negative 3? No, it's not. So I discard that solution, and the only solution that works is x equals 0. So on this one, you must check. It's required, because by squaring, you can introduce extraneous roots. Now let's contrast that with this kind. With rather than seeing a radical, you see something that's been squared. It's been isolated, so to undo that, we take the square root of both sides. The square root of this is 2x minus 3. Square root of this is plus or minus 18. So 2x minus 3 equals plus or minus square root of, I'm going to break this down. I'm going to pull out the 3, and I have 2x minus 3 equals plus or minus 3 radical 2. I need to continue to solve for the x, so I'm going to add a 3 to both sides, and here is where you have to be very, very careful. 3 and 3 radical 2 are not like terms, so all I can do is write 3 plus or minus 3 radical 2. I can't combine those and call them 6 radical 2 because that isn't true. Last step is to divide by 2, and I get x equals 3 plus or minus 3 radical 2 over 2. And I can't do anything with that. I'm also not required to check it because I didn't square anything. So what you need to remember is, if you see a square root, the way you get rid of it is to square. If you see something that's been squared, the way you undo that is to take the square root.